Hello, everyone. Welcome to our bi-weekly core protocol sync. Today, we'll be going over what we've accomplished in the last couple of weeks, what we plan to accomplish in the next couple of weeks, as well as any kind of outstanding discussions that we need to have. To get us started, Nazar, I know you've accomplished quite a bit. So,
Yeah, as of last time, we had initial implementation of the consensus kind of ready. It was merged and everything. However, there are problems with performance, and that's what I was spending a lot of time this week and previous week. And we do have some improvements. Like on my machine, initially it was like taking 1.5 seconds, something like that, to run the proving part only. And now I can do the same within like 600 milliseconds ish, which is about 2x improvement. There is still room to improve though. What did happen was a few improvements in Rust KZG library. So we have improved the ratio coding recovery performance. It improved about 2.5x, primarily thanks to parallelism. So we do more things in parallel. We don't necessarily save any resources. We just do more things in parallel. And then there was an optimization of a single proof creation, which we call witness. Basically, they have a way to create one witness or like one proof that covers multiple values. And then there is a special case where you have just one value. What they were doing, they were just calling that generic function that supports n with 1. However, if you actually like inline all of those like nested functions one into another, and you substitute the values, and then you think about the algorithm, a lot of computation was actually wasted. And the biggest contributor to that was that they were doing division by 1, which naturally almost in all like field elements or anything will result in the same result. But it was using some low-level assembly instructions. It was not trivial. Neither compiler nor CPU can understand that it is actually division by 1. So I just removed a lot of that and improved performance about 3x. In this case, we are not doing work and not just like parallelizing. So this is better. With those, I was able to get to 600 milliseconds or like 560 milliseconds, something like that. The next big chunk of time we are spending is proof of space from Chia. We were running still all of the 4 phases, 3 of which we don't need. So I was working on that. There is ongoing re-implementation. We are debugging it with Daria right now. It seems to do what it's supposed to do, but the results are slightly different from what reference implementation from Chia produces. But the performance is kind of close to C++ implementation of the first phase, but we only have first phase. So we are saving quite a bit. And if we go to smaller tables, like Daria suggested, like we maybe have several tables which are smaller that we can do in parallel, then we would be able to shrink the wall clock time while doing about the same amount of work. So every time we make the table smaller, we do less work. I don't really see a lot of further improvements to be made. It is quite memory hard, which is kind of expectation that we had going into this. And also, there is really no room for parallelism there. Like every time I add something that parallelizes things, it gets slower because it spends so little time on every single small thing that moving things into the thread and back is more expensive. So I was even dumping the assembly of like what it does, and I generated the code with the generics in Rust. So it's unstable and incomplete feature. Like there is a warning that it's incomplete. However, with those, I was able to explain to the compiler quite well what I'm doing, and it was substituting exact values into like bit offsets and stuff like that. It wasn't like calling a function which is generic or like expects like any number. So it was able to compress values quite a bit. And if you change k, it will recalculate everything. It will generate the most optimal assembly for that particular version. So I think we are quite close to the like limit of what can be done. And once I finish that with debugging and it actually works properly, then I will bench everything and see what is the next bottleneck that we have. I was also thinking today what we can do about it, since we still are quite heavy, or like it takes quite a long time still. Even with all optimizations, let's say it takes 300 milliseconds or 400 milliseconds. What it means is that when we have a block time of 1 second, we will spend like 30-40% of the time just doing the proving, which means that a lot of block time that we kind of have, we cannot spend on actual execution of bundles or whatever we need to do, which is unfortunate. And I think if we modify things slightly, we might be able to do an interesting trick where we will try to produce a block while we are still proving. Because I don't think you need a header or like all of the values in the header while you're executing the block. You just need the parent block information. So maybe we can do that thing in parallel, and then at the very end we can like slap it on top somehow. That way we can do those things in parallel, so we will not cut into the block time. But I'm not sure. So yeah, for this week and next week, the plan is to finish the Chia stuff and re-benchmark everything. There are still some optimizations I know we can do because I was using the bitVAC crate, which is really nice in terms of API and features. Like you can address bits in data structures very conveniently. It's not that fast, especially because there are no specialization in Rust, at least not in stable anyway. So when I replace that with manual code that does bit addressing in a proper way, like bit shifts across slices and stuff like that, I was able to 2x improve performance. So we are still using bitVAC for some things, and we can probably cut some milliseconds by eliminating that. But yeah, I think we can go back to the research side and figure out if we can do something a little bit different in the same spirit that will allow us to at least parallelize it. I'm not sure how much opportunity we have in the linear time, but at least parallelization for some algorithms might be possible. So yeah, I think that's the gist of what I was working and planning to do.
So if you've got times down to, what would you say, 600 milliseconds on your machine?
So time will take about 175 milliseconds on my machine. It's quite high frequency, so let's say 200 milliseconds. And then on top of that, we need to do ratio decoding and other things. So it will not be like 100 milliseconds. There is no way.
Right. Okay. Great. Daria.
Well, I was mostly for the last 2 weeks supporting the Nazar's efforts, basically. So I have been untangling the Chia documents to answer various weird things that they're doing in the code and places where they don't really match with their docs and the code. We have, so I have written a sort of specification which doesn't have all of the weird things that they're doing in the code, but the things that are needed for a proof of space to work properly, which is not exactly matching Chia. And for what Nazar has implemented right now and all the bugs that we have caught so far, it's able to plot all of the needed tables and query them for quality, which is like the short proof that we use for encoding. However, right now it finds all of the needed qualities that Chia finds, but also a few more. And I have been spending the last couple of days, trying to catch what exactly is there, and I'm still not able to. Though I also caught a couple more bugs along the way. The things, if I'm not mistaken, we're still missing is fetching a full proof and actually verifying it. And I do feel like we can proceed with the qualities that we have right now. Like, okay, it finds a few more proofs, but I can, try to catch them in parallel with, it doesn't prevent us from actually using it. Yeah, go ahead, Nazar.
Yeah, I just recalled what can cause that. So I mentioned a few times that C++ seems to work by accident. Like it works in some cases, it crashes in some other cases. So we actually have try catch in the code, and we did like throws an exception for some reason, like something is buggy in the code. It will actually just return you that there is no proof, but maybe there is. It just is not able to produce it. So maybe modify C++
Okay.
at least to print a message, so we know that there was something there, but it wasn't quite able to produce it, and maybe that's the reason.
Could be because it like our implementation finds like 25 to 30 more proofs out of 130,000 proofs. So it like matches in 99%. It finds just a few more. And another thing is that like Chia like doesn't actually store those entries from the table and doesn't store all the like extra bits. So it could be that they are dropping something that we don't know what it is. So and I'm not sure how much more time I should actually spend on it because like I am going crazy out of this. So we should proceed right now, I think, with trying to use it as it is in the protocol, and then we'll catch the bugs along the way without actually trying to replicate it to every single bit. And then I will try to catch them, as much as we can. So that's there that I was been working for the last week, and that I will be working this week as well. And I will communicate all of the things that we have seen with numbers and memories and tables in the Chia things to our researchers that are Chen and Barak, and try to hear on their suggestions of what we can and cannot do in our case to improve performance, but not sacrifice on the security. And another minor thing that I was spending a few hours on was helping Part with figuring out how can we verify in Solidity our consensus right now.
Great. Rahul.
Hey. So last week, we have the upstream changes out for review, but they probably won't approve it until the next release of a substrate. So we decided to go ahead and merge it in our fork and start using it. So that was the first thing I did early last week. That change was merged into our fork, and we switched our monorepo to use that new version. Then I made the compact block changes based on that, and it's out for review now. I just saw a bunch of comments from Nazar. I'm going to address them today, and then hopefully we can merge it. And I have some follow-up changes coming up. Like I want to add some metrics and other things before we enable the flag. It's a flag control, so by default it's turned off. So hopefully by this week we will have it actually enabled in. I need to figure out the rollout plan. Like, do we want to first enable it in like DevNet or what kind of thing? I may reach out to Nazar or someone about how we want to do this thing. So that was the main thing I did last week. And then I had to do some. I tried to do some benchmarking. I created a VM with 2 CPUs, and it didn't actually come up after 1 hour. Because the farmer is taking like 250% CPU. I think today I'll go back and try to create another VM with like maybe more CPUs and see how it goes. So do we have any like recommendation for like the minimum configuration we should have now in terms of VMs?
I think it's more about the plot size at this moment. If you specify something like 100 megabytes, it will probably be able to do that. Otherwise, it will be spending a lot of resources plotting.
Yeah, I actually tried 50 megabytes. I think the minimum is 36 megabytes or something. We gave a message. So I right now I'm at 50 megabytes. Yeah, let me go back and try. Maybe I should try 4 CPUs or something, or 8 CPUs.
Yeah, there are also, if you're using Docker, DigitalOcean, there are different kinds of machines. There are CPU optimized and general purpose. So CPU optimized is the way to go.
I see. Okay, I'll do that. So that is mostly from me. I saw some comments from Nazar. I'll address them today. And I'm also working on the slides for tomorrow. for the next things we want to do on the scalability, performance/scalability front. And one other thing is like I want to start looking at like extending this compact block core execution. Is there someone I can talk to on the execution side to get an idea? I have some questions about that.
Kuchang.
Okay.
Yeah. So I believe on the execution side, you mentioned the compact bundles, right?
Yeah. Okay. Maybe I'll set up a meeting with you this week whenever it works for you. Right now, the way I've implemented compact blocks is it should be reusable for both consensus or execution or any other use case. It's kind of abstracted out. So hopefully I'll be able to make the changes for execution. But I want to learn how to actually test it and so on. So I'll reach out to Lichun this week and set up a meeting with him. Yeah, that's it from me.
Great. Well, great. I have, so for the next part of the agenda, revisiting some of the things that were just brought up. So I'll just go down the list here. Offsite presentation prep. I guess just want to make sure everybody's kind of working on that for the meeting tomorrow. Just benchmark consensus improvements on more standard hardware. Have you done any of that, Nazar? Like, do you have another like on a VM? Or?
No, not really. The other teammates were running it on a variety of machines, so I think it should work better than I expected to. The reason for that is that one of the bottlenecks is the memory bandwidth, which is not that drastically different between different machines. Like 2x maybe the most you can see. It's slightly less. And also there is a lot of places where it tries to do parallelism, but it only is able to load my CPU on like 20-30% of CPU core. So even with 3x less CPU cores, you should be able to do about the same theoretically. So I'm kind of hopeful, but it wasn't working that well on my machine to bother benchmarking on other machines yet.
Okay. Yes, Daria.
I just wanted to say that my machine is not as powerful as Nazar's, and he was able to get even mine at under 1 second a little bit. But also, like, my machine is a Mac, so it's not really a common hardware for our farmers. There's like 2 Mac farmers on the whole Gemini. So.
How far are we away from Raspberry Pi? A long way.
Very long way.
Okay. All right, Daria, I know you've been working with Parth on the Solidity Light client. I've been following that pretty closely. At least what he's got a document going where this have been reporting back to me. A couple of blockers, and I saw this mentioned. Nazar commented on this. Blake 2 or Blake 3. I guess there's not a precompile for
Blake
that.
3 is more memory heavy in terms of the footprint rather than computation. Computational wise, it's actually extremely fast. So that's the benefit. It takes less time, but it uses more memory.
It is like 10-fold more memory than Blake 2 on average.
So for Solidity, it is a problem, but it's not a problem for many other use cases.
Okay. So is this something? So I guess what I'm trying to determine with Parth is if it's just not feasible in Solidity to do a light client for Subspace.
So Blake 3 is probably not feasible. The elliptic curves for KZG probably are. So there was some suggestions to add a precompile for the BLS curve that we're using, but it's been there for 3 years and they have been pushing it away. So we have no guarantee it will ever be there. There are other implementations. There is one implementation in Go in the official client, in the Geth client, that he could probably convert to Solidity, but we didn't know how much it's gonna actually cost to call that. So that's one thing. We could do a sort of lesser security light client that verifies only KZG but does not verify Chia, like halfway in the middle, but we should think about that more.
Okay.
Chia is probably, unless we get rid of Blake 3, and instead, a part of Blake 3, there's also Chacha random generator that is used to, like, with the verifier as well. That's probably not going to be really doable in Solidity, or too costly.
Yeah, I saw the
It
comments.
would have been nice if Ethereum could introduce precompile for the Blake 3. But it might take years to actually get there. So
yeah.
So the precompile for the BLS was actually suggested to add in the Shanghai upgrade, but they pushed it back to the next upgrade. And in the next upgrade, it's also is considered. So it's not guaranteed they're actually going to push it. So.
All right. So we may just need to think about alternative means of doing either not doing a light client or like what you said, just verifying the KZG. You think about what the implications of that are. On the research side, has anybody like been focused on bridging and kind of or all right. I guess this will be a topic for our offsite. So I'm sure we'll have a lot to talk about. Rahul, you mentioned rolling out changes for compact blocks. I do think we should try this on DevNet. We should be getting a new DevNet up. I don't know if your changes are going to be, like the DevNet should be up today. Your changes may be breaking. I guess I don't know. Or will they just be client?
Yeah, there are no breaking changes as long as like because the Subspace, I mean the Substrate fork has been already switched to the new changes, so it should be able to work as is.
Okay. So this week, once you get merged, I guess we can take a look at that, unless you feel we should test that prior. Now we'll probably wait till you get merged and then.
Yeah, so I'll try to once I address the comments and get to like almost final shape, I will deploy it on testnet on the DevNet.
Okay. I know this isn't a domains call, but since you're here, Liu Cheng, we were talking. There was a question I asked about Gemini 3D versus 3E on re-enabling domains. Did you ever? I didn't see if you commented on that.
Yes, Veda has asked like my preference is to have them like enabled again on current Gemini 3D, and I believe Veda already seen that.
Okay, so they will be on 3D. Is that what you said? Okay, cool. Good. That'll help with the core EVM deployment. So, and then I see Nazar, you already answered my question on the idea you had proposed.
Yeah, I think that's something that I don't really have very good tools to measure. So when I'm doing measurements with perf, it will measure everything that happens to the process, which means it also includes some initialization stuff. Let's say deriving the public parameters for KZG, which decompresses the data from the file and does a lot of stuff, which takes like a few seconds of work. So if the benchmark itself is like 10 seconds, let's say, it means that that initialization part takes significant amount of time, and it will be reflected in perf results. So I don't think that the erasure coding was taken that much, and I already improved it a little bit. So I think we will stop there. But something like splitting one table into two and generating them in parallel will mean that we are kind of doing the same amount of work, but at the same time, when we are proving, we only need one of them, and we also can do it twice as fast. But there is a question whether it impacts protocol in any way in security-wise. So I think there is still some investigation to be done what we can do on like architectural level of like design of the protocol, not necessarily implementation.
I was going to say that if you are, Jeremy, referring to the results of the perf that we discussed in previous meeting, where there was one operation that was taking like 30% of time, we actually determined that much of that is not erasure decode, it's actually KZG. So that was
That's
not
why I went
reflected
into
in the
the
comments.
into
Yeah.
witness generation. That's why I was looking why
Well,
it's so
I
slow.
suggested in the meeting it was KCG, and it was. So
It still takes time, but not as bad as we thought. Go ahead.
So Rust has this criteria bench create, right, where I think you can do the initialization and it lets you benchmark only the required parts. So I don't know if that helps.
Yeah, we are using Criterion for benchmarking purposes. The thing is that I'm running it under perf, and perf will capture everything in the process. But there is some initialization before we actually run the benchmark.
I think then the only way is probably do the initialization and store it in disk or something, and have it initialize after the disk state or something. That would help. Yes.
Maybe I can initialize it and then like sleep for 10 seconds, so I have time to run perf and connect to the running process instead of starting it with perf, so I can skip some of the results. I don't know. There are some opportunities there, but yeah, there is still improvements to be done.
Yeah, you could
So
maybe move that to a different process, like initialization happens in a different process, and it can send it over a channel.
I don't think it will be the same process. It's a different thread maybe.
No, I'm saying like you can split that into two processes so that initialization happens in one, and the initialized results are sent over a channel to this other process.
What I mean by initialization, we have a blob of data from which we decompress in memory data structures for KZG. So we need it in memory. We cannot just like send it.
Okay.
So there's some experimenting, it sounds like, that could be done with table size and such. Like, have we actually experimented with that? Is this theoretical? Are we concerned about security? Is that what?
With Chia proof of space, the problem was it was very buggy, and with K16 it was very, very buggy. It was really unusable. Now we can run it, and I can see that it is under 100 milliseconds for K16. So if you can do to K16, that will be much faster. But I don't think we've done a lot of experimentation in that regard. A lot of these like improvements, they actually break security, so it's not that trivial.
So
yeah,
what's
because
it?
if the table is like too small or takes too little memory, there is like the biggest attack is that an attacker can store just the whole history once and a bunch of Chia tables instead of storing all the pieces properly encoded. So we cannot make it too fast or too easy.
Yeah, also CPU caches are quite big these days. So if you have a table that fits into cache completely or like significant part of it, that also impacts the assumptions about memory access and stuff like that.
All right. Final thing was GitHub issues. I think we need one for compact bundles. Rahul, if you could, like, even if you don't have a lot of details, just kind of use that to get started, just so we can track it.
Yeah. So you want me to create a GitHub and separate tracking thing for that, or?
Yeah, for compact bundles.
Compact bundles. I mean, from the execution side.
Yeah, from the
Okay.
Yeah.
Okay.
All right. Is there anything else anybody wanted to discuss? All right. Well, I guess we will stop the recording here then. We'll see you then.